Hello, Earthlings. So, Ethereum is great. We want to take it to more planets than only Earth. And when we think about space frontier, often nerds think about the space frontier as some sci-fi or alien technologies. Or for some other people, it's just an empty void, which is slightly less inspiring. The reality is that if anything of value is going to come out of it, we need to get nuanced and work with the complexities. So what we have seen is that in the last 2 years alone, more satellites has been launched into orbit than in the previous 5 decades combined. So after decades of stagnation, we're entering a space acceleration era. And this is the time where democratization of the space industry is happening, and plenty of startups with wild ideas are finally taking a stab at implementing their stuff. With SpaceCoin, what we're building is orbital root of trust. It's literally out of this world secure hardware, out of reach of physical attacks. It's space-based trusted execution environment, or we call it SpaceTEE. And this serves as infrastructure for celestial compute marketplace, payment layer for satellite services, and from Earth, we'll be able to access it via RPC nodes for EVM and other networks. This is a real photo from a launch not long ago. What we've built with the SpaceTEEs is infrastructure with our aerospace partner, CryptoSat. We basically designed, built, and launched satellites into orbit since 2021. Last year, we contributed to the EIP 4844 with the trusted setup ceremony, the KZG, aboard the satellites. And the latest satellites are equipped with the Iridium connection, which is reachable from any place in the planet. And now we're preparing a set of nodes that will be equipped with more Iridium antennas, sea-edge nodes. Yeah. And essentially, yeah, this is immune to any kind of attacks there. The architecture is YangWao's session.
Okay, thank you for Mike. Thanks, slides. So this is actually what you see is like the network architecture, which actually is like network resilient. So we are using the Iridium satellites, which have like the 66 pieces distributed across the planet, with the 9 in the backup. So there's like the first line of our communication path we are using. Then we are using the Aptos orbital, which is like provide us the computation infrastructure currently. And thanks to this, actually, we are building the SpaceCoin on the top. So what actually we can build on thanks to this is actually like some kind of protocol with specific hardware capabilities, and it will be like resistant to any kind of the DDoS attacks and the censorships. And in the future, we believe there will be like much more, a lot of communication, the paths we can use and the computational capacity we can get. So this is basically like a brief diagram where actually the satellites are reachable any single moment. So you can see like in any kind of the intervals, some satellites are actually reachable where actually the ground stations are the proposing and then actually the electing and the voting back and the broadcasting back on the ground stations. So what we are using this because there's a lot of constraints in the environment is actually we used the modified hot stuff 1 with the instant finality. And thanks to this, we've retrofitted for our lower bandwidth with the least amount of the messages needed between the satellites. So, and this actually opened us the requirement, like we just need for the connectivity only one node, designed it as the leader. So this is briefly like the diagram. So how actually will be like working in the future and what we are looking forward to implement currently. So we'll have like the pre-finality on the L2, with the pre-finality with L2 as with the L1 backup, whereas the state is posted on the L1, which is actually good for the low-value transactions, and for full finality, we'll be using the L1, where actually it's good for the high-value transaction, and actually the state will be fully committed to the L1 on the satellites. So for the security services, thanks to this, we can like offer like the SpaceTEE, the coprocessors, which enable FAG cases. For that, actually, we are looking forward to offer like the secure custodian for the various key management systems and schemes. Then actually, we're looking for the cosmic entropy and the VRF. And thanks to this, actually, we can offer some kind of the secure deletion because like the hardware is like inaccessible for the inspection and the eternal bulletin board. So what we're actually looking forward up there is that we'll be implementing the support, the EVM compatibility. And we'll be looking forward to the initial deployment, focusing on the bridge contracts, and for future extensibility through the WASM, risk, and VM-based stuff. So we are looking like for the L1, L2 foundations, MPC wallets, and the validators, and especially entropy providers as well. So thank you for the attention. Please give us the follow on the Twitter. And I think now it's time for the questions. Thank you.
It is. Man, peace among worlds. So, do we have any questions? Remember to stand up your hand, and I will toss this to you.
Yeah, you can have any kind of the questions. We can answer some physics there.
Oh. Will be delivered to you. Don't worry, it doesn't break.
So this is fascinating to see. So, like, you know, hats off, like, for building it. What happens? Is it harder to patch because it's in satellites? Like, you know, on Earth, I guess you could upgrade the hardware or, like, you know, switch over to a different operating system. Like, you know, if there's a vulnerability in the OS that's running on your satellite, I imagine that's a lot harder to go and fix. So how do those challenges come in? And the second one was, what happens if one of the satellites fails? And can you still maintain connection between your L1 nodes?
So there's redundancy, right? You have actually on each of the units, you have two Linux, like hardened Linux machines, and then eventually both you have the redundancy in case one satellite goes off. But with regard to patching, ignoring for a moment the hardware-related stuff, which is a longer conversation, but for software, we're actually looking at potentially implementing some kind of committee sign-off. So essentially, you have it both peer-vetted, and also it's not just like a centralized entity that patches and pushes potentially man-in-the-middle, you know, unnecessary things.
If I understand correctly from your slides, that you use Iridium's satellite.
Correct.
Okay. I understand SpaceX has a lot of low orbital satellite. But why do you choose Iridium over SpaceX?
Okay. Yeah. So for currently, like the Iridium is like this, like it's most oldest, but it's actually most reliable you can get right now. It's also expensive, but it's actually, thanks to it, where it's actually in the constellation, is actually quite have a long sustainability of the networks. But yes, the Starlink and other providers, they're actually coming in the path. So we believe there is actually in the market on the optical terminals, but we are just wait the satellites being up and ready. So now Starlink, yeah, will offer for the satellite providers, but it takes time to implement it in the orbit. So once we'll be like more viable and of course cheaper option, we will like switch to that also and have like the redundancy.
Thank you.
Okay.
Any more questions? Yeah, there's from
Last question.
Thanks for the presentation. What are some first use cases you envisage, and what are some really moonshot or literally moonshot use cases that you can see potentially, or what could be the coolest use cases you can foresee?
It's a bit of a long story, but I reckon just some of the use cases, cosmic randomness for VRF, secure deletion, MPC application with co-signing, secure co-processing. These are the things that are applicable already today. What's maybe moonshot and very interesting is, as we showed, there's so many launches now. There's like an entire new space native economy, right? So we foresee a scenario where there's going to be AI agents in space making decisions without having to download data to Earth. So eventually, like, there's a lot of security that is required for this to happen. Like we've seen with Planet Labs how it influenced security on Earth. And with more assets in space, it's becoming much more sensitive. So we foresee it as, you know, at the backbone for expansion of Ethereum into more planets eventually, or at least outside of pure bounds of Earth.
I would like to say the moon cases is like the payment network between the satellites. So yeah, that's how we see it.
All right. Please give a big applause to these guys. That's a wonderful presentation. So